Now we're going to talk about what is called a stem and leaf plot. What a stem and leaf plot is it consists of a vertical line on which each value is denoted by a digit. The numbers on the left side of the vertical segment are the stems, and the numbers on the right side are the leaves. When the data is ordered from least to greatest, we call this an ordered stem and leaf plot. There are many advantages. It can be created easily by hand. It's a very nice way of looking at it, data and putting things in order. It does not become unmanageable when the values become large, like if you have in the hundreds or thousands. And none of the original data is lost with the stem and leaf plot. And so those are some major advantages to stem and leaf plots. But let's actually look at how to create these. First, we need to find the highest and the lowest values of our data. So we look here, we're looking at test scores for Mrs. Johnson's class. So again, I'm going to do a title. So test scores for Miss Johnson's class. And then I'm going to identify the high and the low value. So the low value is 55 and the high value is 99. So the first digit here will be my stem, and only one digit here can be my leaf. So if you have more than 2 digits, then you can only have one digit for your leaf. So for example, if you have 103, 158, your leaf would be the 3 and the 8, where your stem would be the 10 and the 15. So the last digit is your leaf. So I'm going to draw a vertical line, and I have to start at 5 because that's my smallest number, and then I'm going to go, not 4, need to go up, increasing, sorry. I need to go 5, 6, 7, 8, and 9 because that's my largest number. Then what I'm going to do is I'm going to start with the 55, and I'm going to put the ones digit on the right side. So I'm going to put a 5 here. On the 6, I'm going to put a 2 and a 5. On the 7, I'll put a 0, 1, 2, 2, 5, and 9. So I'll have a 0, 1, 2, 2, 5, and 9. In other words, for all of the ones that start with a 7, I need each of their last digits. Even if they occur more than once, I need to put that last digit more than one time, because I need to have the same number of leaves as I do original data points. So then for the 8, I'll have a 2, a 5, and an 8. And then for the 9, I'll have a 1, 5, 7, and 9. And this, I also need a legend that tells me, and I can use any one of these numbers, but I can use a 5, 5, and all I'm going to do is say that that equals 55. Because sometimes we do use decimals, and if I had 4.3, 4.8, then I would have a 4 and a 3 like this, and I would need to have a legend telling me that that line would mean a decimal place. In this case it does not, so I need a legend that tells me this. let's look at a back-to-back stem and leaf plot. This is where we're going to compare two sets of data that are related. So like Mrs. Johnson's classes. So we're still going to look at scores in Miss Johnson's classes. But now we're going to have her first period class and her second period class. So we're going to have her first period on the left side and her second period on the right side. And we're going to have the stem in the center. And so we're going to start with our 5 and go all the way to our 9 as our stem. Now the second period is going to look just like we did just a moment ago. On the 5 it'll be a 0. On the 6 it'll be a 0, 1, and 9. On the 7 it'll be a 0, 4, and 7. On the 8 it'll be a 1, 3, 3, 9. On the 9 it will be a 0, 4, 5, 5, and 7. The difference is on this left side. Here's your stem. You always want to start with the smallest number closest to the stem. So on the 5, we're going to have a 5. On the 6, you're going to start with the 2 and then put the 5 on the left side of that 2. Again, you start at the stem and then you go larger from the stem out, whichever side you're starting with. And then we'll have a 0, 1, 2, 2, 5, and 9. You'll have a 2, a 5, and an 8. You'll have a 1, a 5, 7, and a 9. And then again, we'll do a legend. And you don't have to do a separate legend for both sides, but you can do 55 is equal to a 55. Okay? Anytime you're looking at a stem and leaf plot, you have your stem, and your leaf always, the smallest leaf always is closest to that stem. And that's what we're looking at when we look at stem and leaf plots. Now, if there's not a value for one of your stems, let's say that one of my stems, let's say Mrs. Johnson's second period didn't have any 70s, okay? What happens is we just leave it blank. We don't put a 0 there. If we put a 0, that represents a number. That represents a 70. So we actually just leave it blank if there's not a stem, or I'm sorry, not a leaf for that individual stem between the smallest and the largest stems. So anytime you do not have a leaf for a particular stem, just leave it blank.